Hi everyone. This is section 7.2 for Algebra 2A. This is continuing with probability, and specifically today we're going to jump into some situations involving the word or. So like, what are the chances of this or this happening? Okay. This is also related to something called the addition counting principle, although I doubt you'll ever actually call it that. But again, this has to do with or situations. What I do want you to do is kind of link these things together, the or with addition. Anytime we're dealing with ors, that's going to be an addition problem, and you'll see why in just a minute. But first, let's get some vocabulary out of the way. So these first two words are words that you have learned before, I think in geometry and algebra 1. So the union of two sets, the union of set A and B, would be the set of all items contained in set A or B, or both. Okay, so if you are in group A or you are in group B, that's great. You're in the union. Okay, and if you happen to be an element, if there's like overlap between the two groups and you happen to be part of that overlap, that's great. You're still in the union. Your symbol here, by the way, looks like the letter U for union. So this is the union of sets A and B. The intersection is a little more specific. The intersection is the set of the items that are contained in both at the same time. So that's that overlap. Like if you were thinking about a Venn diagram, it's that middle area on a Venn diagram. Symbol for this one is A with like an upside down U and B. That's the intersection. This word is probably a new one. Mutually exclusive are two groups that share no elements in common. Okay. So, for example, if I looked at my 6th hour class and, let's see, Mr. Ugansky's 3rd hour class. I have no idea what Mr. Ugansky teaches 3rd hour. But there's a possibility that there's overlap, right? So the union of our classes would be everyone in my 6th hour and everyone in his 3rd hour. And if you happen to be in both, then that's great. You're still in the union of the two classes. The intersection would only be those people who are contained in both classes. So only the few people who happen to have Mr. Ugansky 3rd hour and me 6th hour. The idea of being mutually exclusive means there's no overlap. Okay, so no intersection between the two groups. So if I were to look at the my 6th hour and Mrs. Elsie's 6th hour, let's just say. It's impossible for any student to be in both of those classes at the same time. So those two events would be mutually exclusive. The chances of me finding a student that was in her class and my class would be 0 because it's impossible. Okay? So that's the idea of mutually exclusive, is that there's no intersection, there's no overlap between the two. Okay, so now we're going to start out with something called the addition counting principle. And again, you're probably never going to call it that by name, I don't think. But the idea here is, how do you add up the number of items in a group? And I'm going to do an example here where I show you a picture. And there are situations in math where you have a picture or a diagram or a table to look at, and you can literally just count up the things that should be included in the group. And if you can, I encourage you to do that. This crazy formula that's here, and we're going to talk about what that means in just a minute, is really only for situations where you don't have a visual model, where they give you some of this information and then you have to kind of fill in the rest. So let me show you what I mean by that. I've got this diagram here with all these crazy shapes, okay? And I've got pink shapes and I've got purple shapes, and I want to know how many, and we typically use the number n to say the number of, how many of these shapes are either pink or stars, okay? How many are pink or stars? So like I said, if you've got a picture in front of you, I would just count. I'm counting 1, 2, 3, 4, 5, 6 pink shapes. Plus I've got a couple of stars over here that are purple. So 7, 8. I would say there's 8 of them. But look at what happens if I look at these things separately. If I count just the number of pink, I think we said there were 6 of them, and I add the number of stars, I count 1, 2, 3 stars, I end up with 9 somehow. Can you think about why that happened? Well, it's because when I counted the pink shapes, I counted this one. And then when I counted the stars, I counted this one again. So this one got double counted. This is the intersection, right? This is the thing that's in both groups at the same time. So what I can do, and what that formula we were just looking at says, is if you know this information and you know this information, you can add them together. But then what we have to do is subtract off however many of them are pink and stars at the same time, which would be 1. Okay? And again, I'm not counting that, or I'm not subtracting that because it doesn't count. I just don't want it to double count. This element got counted in this group, and I don't want to count it twice, so that's why we subtract it back off, and we end up with 8. So that's really what this formula is saying here, that if you're trying to count up the number of items in group A or group B, you can add together the number of items in A with the number of items in B, and then just subtract any intersections so that you're not accidentally counting them twice. Okay. Now, if there's no intersection, you don't have anything to worry about. If I wanted to know how many students are in either my 6th hour or Mrs. Elsie's 6th hour, I could just add our 2 classes together and not worry about that overlap. Okay. Okay, so let's take a look at that example 1. It says 13 of the 50 states include territory that lie west of the Continental Divide, and 42 states include territory that lie east. But altogether then, if I've got 13 and 42, that gives me 55 states. And we know that's not real, right? That can't happen. What's happening here? Okay, if you were in class, I'd be asking you that question. But I hope that you're catching on to what that means is there are 5 states that overlap. So there must be 5 states, because we know we need 50 states total. There must be 5 that have territory on both the west and the east. And so those 5 states are being counted in both of these groups. So now let's apply that to probability. And really you'll notice that this probability formula, which remember this symbol here, the union symbol, is really the same as or. The probability formula looks just like the counting formula, right? The number of items formula. That if I say what's the probability of this happening or this happening, you can add together the 2 probabilities, but then just make sure you subtract off the overlap so you're not double counting it. Okay? So we're going to apply that formula and talk about dice here again. Let me find my dice sheet. If 2 fair dice are tossed, what is the probability that the sum is a 2 or a 3? So the way we're going to approach this is we're going to say, what's the probability of getting a sum of 2? And we're going to add the probability of getting a sum of 3. But then we're going to subtract the probability of getting a sum of 2 and 3. And if that's freaking you out, it's okay. We'll talk about that in a second. Okay, so looking at our dice sheet here, help if I turn it right side up. What's the probability of getting a sum of 2? Well, there's only 1, right? This is the only way to get a sum of 2, a 1 and a 1. So I would say the probability of getting a 2 is 1 out of 36. Now, what's the probability of getting a 3? Well, that would be here and here. So I'm seeing 2, right? So I would say 2 out of 36. Now, do you see any combinations on here where you're getting a sum of both 2 and 3? That doesn't even really make sense, right? You can't get 2 sums at the same time. Those sums are unique. So this is impossible. There is no overlap, okay? These 2 events are mutually exclusive. There is no overlap, which means that this probability is technically a 0. So we can still say we're subtracting it. It's just a 0. And then we get a grand total of 3 out of 36. Now, the other thing you could do with something like that is you could just start counting, right? I say I'm going to count all of the 2s or 3s. So here's a 2, here's a 3, here's a 3. All together in one round of counting, I counted 3 out of 36. So that would work for you too. Okay, if 2 fair dice are tossed, what is the probability that the sum is a 6 or doubles? I'm going to try to do this without looking at the dice sheet, and then I'll pull the dice sheet in a minute, but I do want you to be able to cope with these You know, you're going to be able to use your dice sheet on everything for me, but ultimately one day if you don't have a sheet in front of you, I want you to be able to work with this too. So let's think of all the ways we could get a sum of 6, okay? So I'm looking for probability that the sum is a 6. And so to get a 6, let's start with 1. I could get a 1 with a 5. I could get a 2 with a 4. I could get a 3 with a 3. I could get a 4 with a 2. And I could get a 5 with a 1. Those are all the ways that I can make 6 with 2 die. And so I just started with the 1 here. I know that having a 6 as my first die is not going to work for me because I'd have to get something on that second die and then my sum would be over 6. So I count 1, 2, 3, 4, 5 possibilities. So this is 5 out of 36. Then I want to say, what's the probability of getting doubles? Okay, so my doubles are 1, 1, 2, 2, 3, 3. You probably don't have to write these to know them, but 4, 4, 5, 5, 6, 6. Okay, and I count 1, 2, 3, 4, 5, 6. So this would be 6 out of 36. And then I want to subtract the probability of getting a sum of 6 and doubles, because I probably counted that twice. And you may know that already. You may be able to see just in my diagram what I counted twice here. Okay, so what are the chances of rolling a sum of 6 and getting doubles? Well, what's the only way you can think of to make that happen? That would be 3 out of 3. Or sorry, not 3 out of 3, but 3 comma 3. That would be like if I rolled double 3s. So there's one way to make this happen. So I'm going to subtract 1 out of 36. Okay, because there's a probability 1 out of 36 that this will happen. So altogether, if I add this, that's 11 minus 1, so I end up with 10 out of 36, which I'd be fine with as an answer, or you can break it down to 5 over 18, or you can make it a decimal, but that would be your answer there. Let's talk about that just using the dice sheet. So let's suppose I ask you that same question, and I say, hey, what's the probability of getting a sum of 6 or doubles? You could just look through this sheet and mark all of the ones that either have a sum of 6 or doubles. And chances are, if you're counting it in kind of a concrete way like that, you're not going to have to worry about the double counting. So like here, 1, 1, oh, that's a double, right? So I'm going to mark that one. Not a double, not a double, not a double. This one has a sum of 6 though, right? Okay, let's go here. 1, 1, 2, 2, that's a double. 3, 2, 4, 2, oh, that's a sum of 6. 5, 2, 6, 2, that's a 4, that's a 5. Oh, that one makes a 6, and it's also a double. Not a 6, not a 6, not a 6. Not a 6, oh, that one's a 6. Here we've got, that's a 7. Oh, there's a double. Those, not any one of those. 1 and 5 make a 6. 2 and 5, 3 and 5, 4 and 5. 5 and 5 is a double. 6 and 5, nope. And then all of these, because they have a 6 in them, I know I'm not going to have any sums of 6 here, but I do have a double sitting down here. So I went through and I just marked all of them on my dice sheet, and if I count them up, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which you'll notice is where we landed, right? We landed at 10 out of 36. So if you just count them, you're not going to double count anything, and so you don't have to worry about doing that subtraction. But mathematically, this is where it comes from. Okay, I think I'm going to stop here and then continue in a second video, just so this video doesn't get too long, and I will pick up with complementary events at the beginning of the next video. So you can go ahead and pause this. If you want to take a look at the homework before you tune into the next video, you're welcome to do that. There's kind of a lot packed into this first lesson. All right, have a great day.